We have another terrific show and an amazing guest here for you today. And we are really jumping into what it means to drive climate neutral or negative, even climate solutions. I am your host, Lisa Dreher, and we would love to welcome you to the Tech and Space Leader Show, where we learn lessons from founders of the next frontier. And I am really excited to introduce our guest for today, Wilson Hago. He is the founder and CEO of Hago Energetics. Welcome to the show, Wilson.
Thank you, Lisa. It's a pleasure to be here, and thanks for the invitation. And it is a pleasure to always tell people about what we're doing because we feel that what we're doing is important, for the future generations.
Absolutely. So I am really excited to hear all about what Hago Energetics is doing. Maybe we can start by having you give just a little bit of background on yourself and Hago Energetics.
Sure, sure. I have a background. I'm a chemist by training. I like to say that, as I remember, as far as age 8, I tried, somebody told me that you can convert charcoal to diamond, and I did a little experiment to do that. It didn't quite work that well, but basically it got me into the whole idea of, okay, how to use science to convert something to something else. Since graduate school, my degree in physical chemistry, I've been worked for a company as an industrial chemist in a different variety of different sectors. One of them being electrochemist as a battery chemist, but also just as a fuels renewable energy expert. Particularly in the conversion of biomass to something to useful chemicals. So that's the genesis of the company that we have today.
Excellent. So, can you walk us through the core technology for Energetics? Why can't I say that? And
Yeah.
specifically, I guess, how it transforms greenhouse gases into usable resources.
Yeah, so the basics of the technology is basically okay. At the underlying, how do we convert something that's wasteful to something that's useful? Today, we see a lot of waste in variety of different sectors, particularly in agriculture, also in the wastewater treatment sector, in landfills, and also in the oil and gas industry. You have an untapped resource in the way of that basically methane is being emitted into the atmosphere. We see that as a potential source of energy that can be captured and converted to something that is to hydrogen that can be decarbonized. So you can use that methane but without burning it and emitting carbon into the atmosphere. We all know that methane is a very potent greenhouse gas. I mean, it's about 80, 100 times as powerful as CO2. So it's kind of a low hanging fruit for us to be able to transform that methane into something that's not detrimental to the atmosphere. And so that's what we're about. We're about decarbonizing industries and how to and converting that nasty methane into something that's useful. And hydrogen is something that's useful in a number of industries. I mean, that's what keeps civilization going. I mean, it's used in the steel sector, it's used in cement making, in transportation, and fertilizers. I mean, that's a primary use for hydrogen is making fertilizers and feeding people. So it's at the crux of the chemical industry, and so that's what we're about basically. How do we contribute in an impactful manner to decarbonizing industries, and then also at the same time, preventing carbon from going into the atmosphere.
This is amazing. Okay, so how does this actually work? What are you taking? What are you doing to it, and how are you turning it into, I guess, carbon negative hydrogen and carbon enriched biochar?
Yeah, so it's all in the process of, okay, we have to capture the methane first, and then we have to and usually the methane that we capture is in the form of mixing with other things. For example, and if we capture it from a farm that has a lagoon pit, you have a material the common is decomposing and emitting all of this methane along mixed in with carbon dioxide and other things like hydrogen sulfide. So you have to capture that biogas, and then you have to take out the methane from that. That's the first order of business, and so that's usually called a biodigester. And then the second order of business is to route that methane through our reactor. And our reactor, what does is decomposes that methane to hydrogen, and carbon. And the trick about for our technology is that the decomposition is made in the presence of a disposable catalyst that's readily available, that's made basically from waste wood, a waste or agricultural waste. So you have a catalyst then that absorbs the carbon from the methane, and both that what we call the biochar and then the carbon from the methane go into the field as a soil amendment to improve, crop productivity, improve water retention, all good things that the plant needs. And so we have a win-win situation where we decarbonize the methane. At the same time, we produce hydrogen that's useful for industry. And so the basis of all of this is to form a facility, a chemical facility that does all of this basically automatically. It has a constant flow of methane. It has a constant flow of biochar through it. At the end of the day, you also have a constant output of the hydrogen and a constant output of the biochar which goes into the soil. So at the basis, it's a chemical facility.
Okay, so how big are these facilities?
They can be pretty big at the moment. We are working with a couple of projects. One of them is in Saudi Arabia, and then the other one is in the Bakersfield area. They're going to be on kind of on the level of the one in the Bakersfield is going to be around 300 kilograms a day, and then the one in Saudi Arabia is going to be several tons a day
Oh my gosh.
of hydrogen production.
Wow, that is amazing. That is amazing. How does the process that you're using, that thermochemical process, differ from a traditional, I guess, green hydrogen or blue hydrogen in terms of the energy consumption and the cost?
Yes, yes, right. So the people love to talk about colors, and I guess it's something to simplify it. But at the end of the day, what matters is the footprint or the life cycle analysis that you can attach. And basically, how does this process ultimately? What is the how much does it emit? Per unit of production of hydrogen produced. So green hydrogen is hydrogen that's made from electrolysis, the decomposition of water and typically you use renewable energy for to do that, solar or wind or something along those lines with a very low carbon footprint. The cost of electrolysis can vary quite a bit depending on location. Usually, I think on the average, it's about $6 a kilogram. And then blue hydrogen is the hydrogen that's generated from a process called steam methane reforming, which produces a lot of CO2. But that CO2 is captured and put into an aquifer, basically buried underground, so that it doesn't do any damage. And that the cost for that is usually $1 or $2 less than green hydrogen, just because you're relying on an old process that's well proven and it's been around for a century. The new wrinkle in that is that you're putting you're capturing the CO2 and burying it. So our process, the methane pyrolysis process, you're preventing also carbon from going into the atmosphere like blue hydrogen, but we're putting that carbon in solid form. So it's being buried, in the soil where it does actually something good. Unlike blue hydrogen, where you just have compressed carbon dioxide and that is buried into a salt mine or something that will keep it for a very long time. So that's the fundamental difference between our approach and then something like that. Plus we expect the cost of production to be lower than blue hydrogen, a little bit lower. So we're talking about $2 to $3 a kilo ultimately.
Wow, that is amazing. Okay, so you have described what you're doing as carbon negative. How do you actually get to carbon negative?
Yeah, so it's all in the accounting and the kind of established rules of accounting, and our process was looked at. I should just say proviso that the carbon negativity it only relates as if you're starting with biogas, because then you're preventing something that would ordinarily have gone into the atmosphere and basically doing something with it. The carbon activity comes from two processes. One is the formation of the biochar. So a plant, takes in the carbon dioxide from that would from the in the atmosphere and then incorporates it into its cellulosic structure, and that ultimately gets the carbon goes into the soil. And then the other part aspect of the carbon negativity comes from the adsorption of the or the capture of the carbon from the methane. So you have the carbon enriched biochar, which is a double whammy in terms of carbon extraction and then putting all of that into the soil. So that's where the carbon negativity comes in. And then we had a process looked at by the third party firm called Eco Engineers, and they did an analysis, and they came out with one of the lowest carbon footprints, for making hydrogen on the planet. So we're very proud of that, and then that's what kind of was driving us, is saying, okay, this you have a way of actually taking carbon ultimately out of the atmosphere.
Oh my gosh. Okay, this is really exciting. So as I understand it, you've done some field tests, one of them being at Harris Ranch Feedlot. Can you talk a
Yeah,
little bit about that?
yeah. Harris is one of the largest feedlots in the state of California. They supply, actually, if you heard of the restaurant chain In and Out, it's very
Yeah.
popular. they supply the they supply the meat to them. And so they have a very large farm. So they agreed to work with us in terms of just doing a pilot of our technology, basically us starting with cow manure from animals on their farm, taking raw biogas, and then using that biogas through our prototype reactor, and showing that we could make hydrogen, ultra pure hydrogen that can run a fuel cell. So that project. It was a very small scale project at the level one kilo a day, but it demonstrated that we could do this. And then the hydrogen was analyzed at the University of California, Irvine, and then it's shown to run a fuel cell. And so that's pretty good news for us. And so, yeah, it laid the foundation to where we are today. Was basically, okay, how do we go from to basically a prototype with all of the basic physics has been established to something that is more of a commercial nature, much larger, so that we can demonstrate then at that point revenues. And then ultimately, I mean, what we are trying to do is basically sell the hydrogen to the transportation sector, sell it to refueling stations in the state as the state builds up its hydrogen infrastructure, but also sell the hydrogen to other sectors. For example, the petroleum refining sector. That needs hydrogen for its operations. And there are other sectors ultimately that we would love to service, but you got to start small.
Yeah, fantastic. So where are you in the development now?
Yeah. So in development, we are, as mentioned, we are commercializing our technology. We're designing much larger units. So, in Saudi Arabia, we're designing the several tons a day unit, and in the Bakersfield, we're designing something much smaller that can power different industrial entities.
Wow. Okay. So what's the big vision? Where do you see this going? Do we end up
That's
being
that's a good question. The vision is ultimately, I mean, the United States is the world's biggest producer of natural gas, and so our vision is that I mean, it's huge reserves of natural gas. We don't think that natural gas should be burned in the carbon sent to the atmosphere, because it will complicate, it will worsen the climate problem. So our vision is ultimately to decarbonize the entire natural gas industry, because ultimately that carbon should never go into the atmosphere; it should go into the soil, and so that's our vision.
Wow, amazing. Okay, so there's also a potential for leveraging this type of technology in space, right? So can you give us a little bit of background on how this technology could potentially be used on the moon or on Mars?
Well, now we're going out on a limb, right? But it's yeah, we did participate in a NASA challenge where we won a CO2 challenge, CO2 conversion challenge award from NASA. Basically, taking hydrogen and carbon dioxide and making ultimately sugars from that to feed future inhabitants of Mars or other colonies. And that's what it's about. Basically, how do you convert local resources to something that's useful? Mars has abundant supplies of water if you kind of look for it. And the atmosphere of Mars is, a very thin atmosphere, but it has carbon dioxide to it. So you can combine those things and make food out of it. And that's, that ultimately you can think about doing these type of things if you kind of have the know-how and willingness to do that.
Yeah, absolutely. Absolutely. Okay, so when do you think one of those projects that you're talking about might go online?
Yeah, yeah. So the we expect to be building stuff in about a year. So after the design and then yeah, hopefully and soon thereafter. Yeah. Once we get the kind of the bigger units up and running and selling demonstrating revenue, then we expect to duplicate that in short order, and then just we expect to see tons of orders. And then replicating it, as much as we can, So, but and then
Wonderful.
we're also interested in licensing the technology so that we don't have to do all the work ourselves uh, and seeing other people kind of work on this.
Sure. Fantastic. Yeah, you could definitely expand faster that way. So wonderful. Well, thank you so much for making time to be here today, Wilson. Can you tell us if somebody is interested in learning more about Hago Energetics, what should they do?
Yeah, well, you can go check out our website, hagoenergetics.com. That's Hago, that's Hago, and energetics, one word. Yeah, and then you can always drop me a line at wilson at hagoenergetics.com.
Excellent, excellent. Well, thank you again for making time to be here today. And I do want to take a moment to thank GuideForce for hosting these sessions. You can learn more about GuideForce at guideforce.com. And we'll see you next time on the Tech and Space Leaders Show.
Thank you for having me. Have a good one.
Absolutely.